Hello friends, myself Vidya Badare, Assistant Professor C Cyber Kolhapur. Friends, in today's session we are going to see Bernstein conditions. Okay. First of all, these Bernstein conditions are used to check parallelism between processes. So, we should know what is parallelism. See, parallelism means use of parallel processing. That is, use of parallel computing paradigm or use of parallel processing paradigm. Or one can say it is means parallelism is the state of being parallel. Okay. Now we will see actual what are the Bernstein conditions. See, there are basically two Bernstein conditions are used to check parallelism. First one is processes can't execute in parallel if one process gets affected by value which is used by other process. Friends, consider we have two processes P1 and P2. Okay? If P1 process gets affected by a value which is used by other process, that is P2, then P1 and P2 can't execute in parallel. And second condition is processes can't execute in parallel if any subsequent process uses data affected by both, that is, whose value might depend on the order of execution. In simple words, this second condition says that if two processes have same output, then that two processes can't execute in parallel. These Bernstein conditions are expressed in mathematical form as follows. Consider two processes P1 and P2 having input sets I1 and I2, where I1 is input set of P1 and I2 is input set of P2, and output sets O1, O2, where O1 is output set of P1 and O2 is output set of P2. And the Bernstein conditions are, first condition is I1 intersection O2 is equal to none. It means that input set of process 1 and output set of process 2 have no element in common. Second condition is I2 intersection O1 is equal to null. That is, input set of process 2 and output set of process 1 have no element in common. And the last condition is O1 intersection O2 is equal to null. That is, output sets of both the processes have no element in common. If these three conditions are true, then P1 and P2 can execute in parallel, and which is denoted by this parallel sign like P1 parallel P2. And if these three conditions gets false, then there is a dependency between that processes and that two processes can't execute in parallel. Okay. Suppose the first condition I1 intersection O2 is equal to null gets false, then there is flow dependency. Second condition I2 intersection O1 is equal to null is false, then there is antidependency. And if O1 intersection O2 is equal to null, if this condition gets false, then there is output dependency. Now we will move to the example of parallelism detection using Bernstein condition. Suppose we are executing any high-level computer program, and each individual statement, that is, each individual instruction of that program is equivalent to single process as below. Suppose we have 5 processes in our computer program, where each this instruction is considered as a single process. Process P1 is A equal to D plus E. Process P2 is G equal to B plus E. Process P3 is C equal to D into F. Process P4 is K equal to E divided by C. And process P5 is C equal to M plus G. Now we have to detect the parallelism between the pairs of these processes using Bernstein condition. And to detect this parallelism, we should go through 2 steps. The first step is we should prepare input and output set of given processes. Okay, and the given processes are like this: P1, P2, P3, P4 and P5. And now we have to prepare input and output set of given processes like this. Okay, see, for process P1, D and E are input, goes to input set. A is output, goes to output set. For process P2, B and E are inputs, goes to input set. G is output, goes to output set. For process P3, D and F are input set. C will go to output set. For process P4, E and C are inputs, goes to input set. And K is output, goes to output set. And for the last process P5, M and G are inputs, go to input set. And C is output, will go to output set. Okay. Now the second step is we have to check all the 3 Bernstein conditions for all possible pairs of given processes. Okay. We will start from process P1. Okay, and we will check all the possible pairs with process P1. First, we will check P1 and P2. See, first condition is input set of first process and output set of second process. If there is any element in common, no. Second condition is input set of second process and output set of first process. If there is any common element, no. And the last condition is we have to check output set of both the processes, and there also is no common element. Okay, so P1 and P2 can execute in parallel. Now we will check P1 and P3. See, the input set of P1 and output set of P3, no common element. Input set of P3 and output set of P1, no common element. And the output set of P1 and output set of P3, no common element. So P1 and P3 also can execute in parallel. Now we will check P1 with P4. See, input set of P1 and output set of P4, there is no common element. Input set of P4 and output set of P1, there is no common element. Output set of P1 and output set of P4, no common element. So P1 is parallel to P4, means there is P1 and P4 can execute in parallel. Now we will check P1 with P5. Input set of P1 and output set of P5, there is no common element. Input set of P5 and output set of P1, there is no common element. And output set of P1 and P5, there is no common element. So P1 and P5 can execute in parallel. Okay. Now we will check all the possible pairs with P2. We have already checked the P1 and P2. So we will start from P2 and P3. See, P2 input set of P2 and output set of P3. There is no common element. Input set of P3 and output set of P2. There is no common element, as well as there is no common element between output sets of P2 and P3. So P2 and P3 can execute in parallel. Now P2 and P4. Input set of P2 and output set of P4. There is no common element. Input set of P4 and output set of P2. There is no common element, as well as output set of P2 and P4 have no common element. So P2 and P4 can execute in parallel. Now we will check P2 with P5. Input set of P2 and output set of P5. There is no common element. Input set of P5 and output set of P2C. There is one common element, that is G. So second condition gets false and P2 and P5 can't execute in parallel. Okay. Now we will see P3 with P4. Input set of P3 and output set of P4. There is no common element. Input set of P4 and output set of P3. There is a common element C. So P3 and P4 can't execute in parallel. Now we'll check P3 and P5. Input set of P3 and output set of P5. There is no common element. Input set of P5 and output set of P3. There is no common element. But output set of P3 and P5 are same. So P3 and P5 can't execute in parallel. And the last pair is P4 and P5. Input set of P4 and output set of P5. There is common element C. So P4 and P5 can't execute in parallel. Friends, likewise, we can check the parallelism between existing processes by using Bernstein conditions. Thank you.